Okay, good afternoon, everyone. Today is the 24th of September, year 2020. Last time, we have discussed the image formed by plane mirror of an point object, where we arrived to our first conclusion. And we have a conclusive remark for the properties of the image of a point object formed by a plane mirror. Okay, and I'm going to write it down. Okay, image distance V is equal to the object distance U. Oops. Sorry. Okay, one student is still coming, right? And for image distance or object distance, it means if we have a mirror here, we have a point object O. Then object distance means the perpendicular distance from the object to the mirror. And it means that we draw a line perpendicular to the mirror starting from O, like this. Okay? And this distance, perpendicular distance, is the object distance. And how to find image distance? We measure, for example, in this case, we measure, okay, the distance of U, 22 centimeter. Okay, exactly here. All right. This is the distance where we should be equal to U, and here is our image. We use this method to locate the image. Okay, first, and then all the light rays coming out from the object O. For example, this one. This is the point of contact, and it will be refracted as if the refracted ray is coming out from the object I. Okay, and so we connect point of contact to point of I like this. And here we can construct the refracted ray accordingly by using the convention solid line before in front of the mirror and dotted line behind the mirror. Okay, now for the point object exercise, we have one here on page 8, the lower part. We are going to do this one first by using this idea or this conclusion. Okay. So first of all, I will draw the diagram, and because I don't have any grid lines here, I need some time. And okay, this is the mirror. Okay, M. Okay, Gary, the person who is standing in front of the mirror. This is the mirror. Okay, and there are four flower plots, A, B, C, D, right? This is flower plot A, and then flower plot B, and then Okay. Speed. Okay, like this. And then last one. Another one. All right, I have 4 points here. Okay, then I have to tackle this example. Okay, the idea is using this one. Image distance equals to object distance for any point in front of the mirror. Now we have 4 points, and then we locate the 4 images respectively. All right. However, the size of the mirror is just this. How to draw a perpendicular distance from the point to the mirror? We consider and regard the line extend from the mirror as the line separating the region. And so the line starting from, for example, point D. For example, we draw a line perpendicular to this straight line, which is considered as the extension of the mirror, even though there are no reflecting surface. 冇反射鏡，塊鏡冇咁大，係咪？不過我哋當係嗰塊鏡嗰條線嘅延伸。個垂線嘅意思咧就係佢喺 D 嗰度 draw a line perpendicular to 呢條嘅 extend 嘅 line， 跟住延伸條線，得唔得？咁咧呢個咧就係 UD。D 嗰個 U 係嘛？我哋咧就喺度度翻咧呢個距離，呢個叫做D pi， 呢個咧就係 image distance of D， 即係呢一個咧就等於呢一個，呢兩個相等，咁 OK。similarly 咧，我哋咧就 draw 呢一個 B 呢度。Okay， 呢個叫 B pi， 要 denote the image of B。咁咧呢個 perpendicular distance 呢個 UB 呢邊咧就 VB。Right？ And then for point A, we will draw the same thing. Okay. 2 units, 1, 2. This is A pi. This is UA. This is VA. All right. Lastly, for point C, we do the same thing. Please complete the draw on your own learning package. Okay. Draw on your own learning package and follow my steps. Okay, 1, 2, 3, 4. All right, mark all the points, all the image behind the mirror by using this idea. Image distance perpendicular to the mirror equals to object distance perpendicular to the mirror. And then we are going to draw one refracted ray. Okay, one incident ray and refracted ray from each point to see if that light ray passing through the mirror. If the light ray passing through the mirror, then it means that Gary can observe the image through the mirror. If the light ray does not pass through the mirror, then it means that Gary cannot see the image of the mirror. Okay, very simple idea. Now, from the point of view of Gary, we connect Gary, the observer, to the image. Okay. For example, we will do point A first. Okay. We connect Gary, the observer, who is the one to see the image behind the mirror. And then if a light ray can enter Gary from this point, this is the image of A pi, and which can pass through the mirror, then it means that Gary can observe the image through the mirror. Okay, so we connect these 2 points. Once again, solid line with an arrow to indicate this is a light ray. Dotted line to indicate the direction behind the mirror. Okay, and where does this light ray come from? This light ray actually comes from the object A. So we connect these 2 points. And complete the ray diagram for point A. And it is clear that point A image is to be observed by Gary through the mirror. Because here we have the mirror here, right? So point A, yes. If you have any doubt, please raise your hand or use your speaker to ask your questions. Okay. Now we will go to the next point, D. For example, D. We will connect G and D. Same idea. Same idea. Okay, however, this light ray passes through this point where which does not have a mirror, and it means that the light ray coming out from D, reaching this point, actually will not be refracted because there is no such a mirror. The mirror is from this point to this point only. This is the mirror. Okay, and this point, which is the wall. Okay, 一埲牆嚟嘅係咪？ An opaque object, an opaque wall, and so the image of D cannot be observed through the mirror by Gary. All right. And similarly, for point B, we will connect point B to Gary. Gary is here, the observer. All right, it's something like this. Once again, the straight line connecting G and B does not pass through the mirror, and it means that the light ray coming out from B will be reflected at this point if there is a plane mirror. However, the plane mirror is only cover this region, and it means that at this point there will be no refraction, and so Gary could not observe the image of point B right there. Lastly, okay, connect the observer to point C5. Okay, and you will find that this straight line passes through the mirror at this point. So where does the light ray come from? It comes from the actual object C. And This is the light ray showing the light from C straight to the mirror and then reflect to enter the eyes of Gary. And so the image C pi is observed, is seen. Okay? So we can draw our conclusion now. The flower pots. Okay? Only A and C are seen by Gary. Any doubt? Any question to ask? Okay, if not, then we will move on. Up to this moment, we deal with point objects only. We regard the object as a point. However, in reality, for example, this chalk, there are not just one point, but many points, right? And in reality, blackboard brush, not just one point, but also points in 3 dimensions, because it's a 3-dimensional object, right? So, in reality, we need to deal with objects which has a extended length, okay? For example, so if there is a real object, how could we solve problems with a real object which has more than one point? Okay, that's our next questions, right? Okay, then move on to the next page. The upper part is an example showing how to use laws of refraction to find out the angle of incident and then measure the angle of refraction and draw the refractive ray accordingly. And so it is not a recommended method to draw the ray diagram like this. Okay, so we will skip this part, okay, to save energy and time. And we will go to the lower part directly, where we have an extended object, O, okay, which is represented by a solid arrow, all right? Okay, and now that we have an extended object represented by this arrow, how to deal with such cases. Okay, in the past, if you have, if you can remember, then how can we draw a ray diagram to show a duck to be observed, okay, by an observer. We choose 2 points from head to toe, right? Choose this point. And then this point. We argue that if these 2 points from head to toe can be observed by one observer, then the whole object from head to toe can be observed by the observer, right? We use the same logic and rationale. We argue that if we choose 2 points from the object, the first one, the tip, A, and then secondly, the toe, okay, the tail, tip to tail, head to toe, okay. If these 2 points, we can find the image of these 2 points. Then by joining these 2 points, we can find the image of the whole object. That's our rationale and the ideas behind. All right. So for point A, we follow this one because this holds for point object, right? For point objects, object distance equals to image distance, and now we draw a line starting from A and perpendicular to the mirror, like this. And then finding UA and then finding VA. We have a point here, which we call A pi. So by using the idea, image distance equals to object distance for point object. And then for the second point, point B, we do the same thing. We draw a line perpendicular to the mirror and measuring this distance, which is UB, and then locating the image with VB equal to UB, right? So it should be somewhere here, B pi. Now we have the tip to toe, the 2 points of the image, and we connect these 2 points. And such image is formed behind the mirror. And so anything behind the mirror, we will draw a picture with dotted line, dotted line. 虛線，我嚟啊，虛線。Okay, we have an image here. And the example 4 requires us to draw the refracted ray of PQ and RS. We will do the same thing. We will follow, just follow, okay? P Q R S. Right? Following the second idea from the previous lesson, any point, any light ray emitted from the point object, from the object, will be refracted as if they are coming out from the image. And that's why we locate the first we locate the image, and then each and every refracted ray will follow this principle that they are as if they are coming out from the image. So from point A, upon refraction, this is point of contact. We connect this point to A pi because the refraction will be seen as if it is coming out from A pi, right? So we connect these 2 points like this. Okay, solid line in front of mirror, dot line behind the mirror. And secondly, for light ray Q, okay, we will join this point of contact to A pi, right? So by doing this, we do not need to measure the actual angles, okay? We do not need to use the contractor to measure the degrees of the angles. And for R, light ray R, this is the point of refraction. We connect this point to the image of B pi, like this. All right. Lastly, EQRS, light ray S. We will connect this point point of reflection from starting from this point. So example 4 finish. Now we will make a conclusion according to this example, because right now we have an extended object standing in front of the mirror, and we, by using our principle, we have find the image, and now we can discuss the property of the image formed by plane mirror. There are 5 of them. Okay. So on page 10, this part, there are 5 bullet points here. Okay, you need to fill in the answers. These are very, very important. All right. Okay, which state the properties of the plane mirror? And there are 5 characteristics, 5 properties. First, it is a virtual image. Okay, we will explain this point later. Okay, later. We will explain the other points first because they are relatively easier. Okay. Secondly, the image is of the size as the object is about the size. Okay, and you can make use of the ruler to measure the size, the length, or the height of the object. Okay. 2 units, right? And measure the height of the image, 2 units. It is very easy to observe that the image and the objects are of the same size. Okay? They have the same size here. And thirdly, the image is upright or erect. Okay, upright or erect. It means if this is the orientation of the image of the object, then the image of the object will have the same orientation. It means the head is still at the upward direction, and the toe is in the bottom, right? Because some optical instrument in some optical system, the image form in some cases will be inverted like this. This is inverted. This is upright or erect. When the object is standing like this, the image is like this. Okay, very easy. When you go to the mirror and observe your own image, you will observe that your image stands vertically, just like yourself, right? So it is upright or erect. Okay, and point number 4, the image is laterally inverted. What does it mean? It means that when you are facing the mirror, the object, the person, raise, for example, myself raise the right hand. Then inside the mirror, the image of me will raise his right or left hand. You try it by yourself by using a mirror and facing a mirror. Okay, if I raise this hand, then in the mirror, behind the mirror, the image will look like something like this. Okay, where the mirror is raising his left hand, right? Okay, and so it means that this is the vertical direction. And so from left to right, this is called the lateral direction or horizontal direction. And so it is called laterally. 打橫 laterally 或者左右。Okay, we come to this point from direct observation. Direct observation. Lastly, the image distance is equal to the object distance. Okay. For a point object, we already know this. For any point, image distance is equal to object distance. So that this is an extension of this idea. Okay. And so with this idea, you should notice that this statement is for any corresponding points of the object. Okay. All right. And because the objects can be very complex, and there are so many points on one object, and it means that for any point, for each point, the object distance of that particular point will be equal to the image distance of that particular point's image. All right. So here are the 5 basic properties of the image formed by plane mirror. Okay, the first one, we call it virtual image. Virtual. Means not real. What does it mean by not real? From the light's point of view, from light rays point of view, because all the light rays, in this case, are to be reflected by the plane mirror, right? And so behind the plane mirror, there is no light rays. No light rays can reach this part. And so this image is formed because of the brain action of the observer, not by actual light rays. No light ray pass through this image. And so this kind of image is called virtual image. Can you see my writing there? Yes. Just at the rim. Huh? Okay, and that is the idea. No actual light ray passes through the image, and so the image is a kind of virtual image. Okay, it's about to finish. We have only 1 minute left. So I'll repeat what we have learned so far in this lesson. Firstly, we learn how to use this idea, image distance equals to object distance for point objects. And with the help of this idea, we establish the image of an extended object from point A to point B, right? And with this diagram and with actual experience, daily life experience, we find out the basic properties. There are 5 of them of any image formed by a plane mirror. They are, first, they are virtual image because this image is not constructed by actual light ray, and there are no light ray in this region behind the mirror, okay, because all the light rays are being reflected, right? And secondly, the image will have the same size of the object. You can take a look at the mirror, okay? The image inside the mirror has the same size as you do, right? And the image is upright, okay? When you are standing vertically upright, the image is also standing vertically upright, okay? However, from the lateral point of view, the things are inverted, 倒轉, inverted, okay? So it is called laterally inverted, 左右倒轉. Lastly, okay, for any point, for each point of the object, the image distance is equal to object distance for each and every point. All right, so that's it for now for this lesson, and I hope you can understand most of them. And let's see in actual classroom next week. Thank you so much, and goodbye, class. Bye-bye.